everyone, welcome to another one of my videos. This one is for Great Minds or Eureka Math, Module 2, Lesson 4. This is division of fraction by a fraction. This is where we're going to kind of put together all the work we've done for the last few days and learn how to divide any fraction by any fraction or any number by a fraction or any fraction by a fraction. So that's what we're going to be doing. Today's learning target is being able to divide a fraction by a fraction. You will be successful today if you know how to multiply by the reciprocal of the divisor correctly, and then reduce and simplify. So those are the two things. We've already talked about these before a little bit, but that's really what we're going to looking at today. And we're going to do this. We are going to look at one example from Lesson 2. That's going to be on page 9, and then the rest will be from Lesson 4. And then there are some con lessons that we'll be looking at too for a little bit of extra help, and that's where we're going to be looking at today with these the next couple days. Actually, we'll be looking at these. So we'll do the lessons today, and then we'll be working on the con lessons. We'll do the problem set also. There'll be a separate video with the problem set on it. Okay? All right, let's go ahead and get started again. So let's look at this first problem here. So we have George bought 4 summery sandwiches for a birthday party, and each person will eat 2/3 of a sandwich. So how many people can George feed? So we've looked at some problems like this the other day when we were dividing by unit fractions on ones like that. We did find out that multiplying by the reciprocal worked for those too. So we know it works for dividing fractions by whole numbers, and it works for dividing whole numbers by a unit fraction. So today we're going to look at it and find out that it does work for dividing any fractions or anything by a fraction, so without multiplying by the reciprocal. Let's take a look. We have a picture of this situation to help us out. So if we look at this, if we can see this picture, we have our 4 sandwiches represented there, and then we show how they're divided up into thirds. And if you notice that, we end up with those thirds, and then if we break those thirds up into 2s, that tells us how much each people would make. So if we look at that, we can just visually tell here how much each person would make. If we look right here, so each one of these, there's 1 person, 2, 3, 4, 5, and 6. So the picture tells us that they can have 6 people. He's got enough food there for 6 people because each person's eating 2/3 of a sandwich. But let's look at how we would do this mathematically and think about that, okay? First of all, we need to know if we knew how many whole pieces there were. Look at what they're doing. They're splitting it up into groups of 2, aren't they? And the way we can figure out how many whole pieces there is we take 4 times 3, just like we were doing the other day. 4 times 3 gives us how many whole pieces there are. There are 12, isn't there? And then we're going to take those 12 pieces and break them up into groups of 2. So we're taking the whole pieces, and we can find the whole pieces by taking how many sandwiches we started with and multiplying it by 3, which is how many each of those sandwiches is broken up into, and that gives us how many total pieces. And then each person is going to take 2 of those, so they end up with just those 2 pieces. So with that, we end up with 12 divided by 2, which is 6. Same as we just saw from the picture. But let's go ahead and look at this another way here. If we look at it this way, okay, so I want to take a look at this. If we look at it this way and think about it, so we can look right here. These 2 numbers right here are reciprocals of each other. So we have 2/3 again. Reciprocal is the flipped fraction. So the reciprocal of 2/3 is 3/2. So if we flip 2/3, we get 3/2. Look what happens when we multiply those just straight across. 4 times 3 is 12, and 1 times 2 is 2. We end up with the same fraction we had over here. We end up with 12 halves, and we end up with 12 halves. So that shows us right there multiplying by the reciprocal does work in this case. and it will always work. And it's because of this idea that multiplying by how many pieces we're cutting it up into tells us how many pieces there is, and then dividing it by the top number tells us how many groups there is. Now it gets a little bit more complicated when we get into other fractions, but that's essentially what's happening. Now we end up with 6 pieces of this. So that's what's going on here with this one. So it does work. Multiplying by the reciprocal does work. So let's look at one more example here, okay? So let's go ahead on to the next slide. So here we have another one. Molly's friend Xavier has 11 cups of strawberries, and he needs 3/4 cups of strawberries to make the batch of tarts. How many batches can he make? So let's look at this. We want to draw a model of this first. So in this case, we already know what's different on this one is we already know how many of the totals we have. We have 11, don't we? We have 11 total pieces because it tells us there. He has 11 of the 8 1/8 pieces. So he has 11 of the 1/8 pieces. And you notice, how much does it take? In this case, the interesting thing is we're looking at 3/4 cups, but if we take 3/4 and put it into 6/8, what we've done is they've got a common denominator here. And this is another method we can use for getting fractions. If we get a common denominator, we took 3/4 and they got it equivalent to 6/8, we get a common denominator, and those, again, remember how we get common denominators? So they've taken 3/4 and multiplied it by 2/2, and we call that a giant 1. That gives us 6/8. Those are equivalent, and now we have an equivalent fraction. But now the nice thing is they're both talking about 8s. So we can just realize each person then is getting 6/8. So what we can do on this one is just take, since both these groups are talking about 8s, we can just take 11 and divide it by 6. Now this works. We can just take the numerators and divide them out if we're dividing fractions, if we have a common denominator. So that's what we're doing here, because we want to know each person needs, or each recipe calls for 6/8. Each tart calls for 6/8 of a batch. Each batch, sorry, calls for 6/8, and he has 11/8. So he can make 1 and 5/6 batch. And we have the 5/6 here is what we have left. So that's what he can do. But notice, if you have a common denominator, you can just divide the numerators to get that. But let's look at this in another way, okay? So let's go to this same problem here. But let's look at it, same picture, but now, if we look at it here, and let's just try the common denominator way. We take 11/8 divided by 3/4, because that's really the problem. We want to know how many times 3/4 goes into 11/8. If we do that, if we take 11/8 divided by 3/4, and then we times it by the reciprocal, so 3/4 times the reciprocal of 3/4, which is, so again, our reciprocal's there. Reciprocal is 4/3, so the reciprocal of 3/4 is 4/3. We times that, we end up with 44/24. And we know we can reduce that by dividing both those by 4. Now if we divide both those by 4, usually I show this though. I didn't change. Usually I show this by putting each one of those in a little division. You can also just do it that way. We end up with 11 over 6, which is the same thing we showed on the other one, which is 1 and 5/6. So we can get that either way. So again, we see multiplying by the reciprocal works. So that's the method that always works. So that's the methods we're going to be looking at and always using. Okay? So let's take a look at this. So, like I said, if we do have common denominators, and this shows up once in a while, if you do have common denominators, you can just take the numerators and divide those out. That is a strategy that does work when you have common denominators. But I wouldn't worry about that so much. The method we want everybody to use, and that last one was, this is example 3. So if you're in your book, if you need to pause this and do that example, you can either do it with the common denominators, or you can still use this multiplying by the reciprocal. So if you notice this, if you multiply by the reciprocal, so again, our reciprocal's here, we end up with 2/3. The reciprocal of that is 3/2. We just flip the fraction and multiply them. So we multiply by the reciprocal, and it's always the reciprocal of the one we are dividing by. It's always this one. Notice the front one does not change. It's still 3/4, 3/4. The front one stays the same. And then we multiply that out, and then a lot of times you can just leave this as improper fraction. I went ahead and went to a, sometimes they'll ask you to put it to a mixed number. You can leave it as improper fraction or write it as a mixed number. Most of the time we'll just leave it as the improper fraction. But again, multiplying by the reciprocal to do that division is what we will do. That is the process we will use from here on out. We will be multiplying by the reciprocal. That's the method we will use to multiply, because it's the method that always works. Okay, so let's go on here. So with these here, I've got some examples worked out. So we got 6/2 divided by 3/4. So if we change that to a multiplication problem, we get 6/2 again. The first fraction doesn't change, times 4/3. And then when we multiply those together, we end up with 24/6. If you need to pause this video and walk through these, you can pause the video at any time and work through these, and I encourage you to do that. Pause the video, work through these on your own, and then use this to check them. Then we would simplify that by dividing them both by 6, because that's the largest one that goes into them, and this one would just go down to 4. Okay, the next one. So we start out with 2/3 divided by 2/5. And then that would be 2/3 times the reciprocal again, 5/2. And notice the front one doesn't change. It's just the reciprocal of the one we are dividing by, of the divisor. It's the one we are dividing by that always flips. And then we get 10/6. What will go into both those? They're both even, so we know 2 will go into both those. So we divide them both by 2 and end up with 5/3. Okay? So again, I would encourage you to stop this video and try to do those, and then use it to check, because you're going to go through the next 3 problems. The video does have the answers and solution for the next 3 problems. If you look at them, they're just on here. One thing I want to look here is you have them. So again, 7/8 divided by 1/2 is equal to 7/8 times 2/1. Then you can work it out. 3/5 divided by 1/4 is the same as 3/5 times 4/1. It's the reciprocal, timesing by the reciprocal. That one, notice, doesn't simplify. Then our last one here, and you can pause this video and work through these. 5/4 divided by 1/3 is the same as 5/4 times 3/1. So that's what you're going to do on all of these. So as you go through these, remember, you can do this successfully if you multiply by the reciprocal, and it's always the reciprocal of the fraction we are dividing by. The front fraction does not change. There's a saying that we've heard and use it all along: keep it, change it, flip it. So you keep the first fraction, it doesn't change. Keep it, change it means we change the sign to multiplication, and flip the second fraction when we're doing division. So keep it, change it, flip it is the way we remember to multiply by the reciprocal. This is what I'm always going to say: multiply by the reciprocal. So work through these problems. There's going to be some Khan lessons showing up in your Khan Academy. Make sure you're practicing those and getting through those, okay? Good luck, and let me know if you have any questions. Have a good day. Bye.